So I haven't made a video in a while. I probably won't. I might be making C programming tutorials, but I'm not sure if I know enough to be qualified on making tutorials for C. But anyways, you might have seen my conic sections video on how to find a conic based on some points. So before we did that unit in my pre-calculus class, as an exercise for myself, I tried to see how you could find a circle with only 3 points. And the argument, it's actually pretty simple. Don't mind this monstrosity here. When you do it like manually with like a pen and paper, and you don't have to account for every point, then it's pretty easy. So as you can see, I whipped up something really quick in Desmos. So yeah, let me just start with the argument. Wait. Okay. So let's say you have a point, 3 points. Point A, point B, and point C. So by definition, a circle that would touch all of these points, it would mean that it would have to be equally distant from every single point. So the distance from point A to the center, and the distance from point B to the center, and for point C as well, would have to be the same. But to first start, let's just find all the points that would have us, all the points of the center of a circle that would touch A and B. So really we only need to find the center of the circle, and we could just find the radius by just figuring out the difference between the point and any single other point. But that doesn't, right now that doesn't really matter. Let's just focus on finding the center. So the obvious first thing would be to get the midpoint between A and B, because this point is equally distant from A and from B. And just through normal observation, you can see that if you make a line like this, all the points in that line would be equally distant from A and B. Now, I don't really have a proof for this. It just sort of seems obvious that this would always make an isosceles triangle. So, but the definition of this line, the slope of this line, would be the inverse slope of the line that A and B make. So yeah, the way you would find this is, let's say A and B make points. AX are defined by AX and AY, and B is BX and BY. So if you want to find, I just realized how tedious this is going to be to write in with variables. But basically, yeah, you just do rise over run, AY minus BY over AX minus BX. That would give you that. If you want the inverse, you would take the inverse. So it would be, let's say m is the slope, you would take m raised to the power of -1 and then subtract. And let's just say that's the new m, or s for slope. Then you would just do x minus where this midpoint is. Let's say a mx, this is getting complicated, plus the y value, so my. Okay, that's sort of going on a side thing. The important thing is that you just have to make a line that's inverse the slope that A and B makes, that goes through the midpoint of A and B. Now, if you do this for C and B, this line would also have make a circle. Would also have a circle that would touch points C and B. So that would mean that if every point on both of these lines make a circle that touches these 2 points, that means the intersection will touch all 3 points. I think that's a pretty simple argument to follow. After that, after we find the center point, let's call this R, big R. After we find that, in order to find the radius, we would just need to find the distance between the center point and one of these other points. And it doesn't matter which one, because the definition is that it's the same distance for all of them. So that would just be, let's see, let's say it's comprised of Rx and Ry, the center point, and let's do A is Ax and Ay. So it would just look like this. I think it was Rx minus Ax squared. Actually, let me check. Yeah, it was Rx minus Ax squared plus Ry minus Ay squared. This is because of the Pythagorean theorem, which is a squared plus b squared equals c squared. So if we have like this point and this point, and we want to make a circle, this is length A, this is length B, the hypotenuse, that would be the radius C, and length A would be this minus the y value of the first point minus the y value of the second point, and the x value of the first point minus the x value of the second point. And it wouldn't really matter if it's negative, because you're squaring it anyway, so that would make it positive. And if you know the standard unit circle thing, so it would be x squared plus y squared equals r squared. So we don't even need to do like a square root to find C. We can just leave it like this. We can just leave it in that form. Rx minus Ax squared plus Ry minus Ay squared. And that's what I did here. This, if you can see, this is the equation of the circle, and this was the center of the circle, big R. The way I named my variables was really inconsistent, so yeah, I did this on paper. I think the conic, the way you do it with systems of equations with conics, is probably easier, maybe easier. I'm not sure. I don't do these. I haven't done the conic thing in a while, but I imagine it would be easier than finding the slope than the inverse line. But I think this is cool. I think it's a pretty simple argument. And yeah, it's just a quick video. I don't really have anything interesting that I'm learning that I want to make a video on. So I think that's I might make a video on how to get copy paste working on NeoVim, and the C tutorial thing. But like I said, I'm not sure if I'm proficient enough with C to make a tutorial, or at least a good tutorial. Yeah, that's all.